Hi everyone, we are going to move from fluid to talking about fueling during endurance exercise. As we have learned in biochemistry and exercise physiology, inadequate energy provision is a major source of fatigue during exercise. This mini lecture will focus on the importance of carbohydrate fueling during prolonged exercise. Research has demonstrated that the single largest determinant of ensuring optimal performance during prolonged endurance events is through the intake of carbohydrate and fluid. On the forthcoming slides, we are going to explore carbohydrate supplementation and the mechanisms of action during exercise. Research has shown that the addition of carbohydrate to fluid provides an additional, independent effect on improving endurance performance. That the majority of studies report an improvement to endurance performance when individuals consume a carbohydrate fluid beverage versus water alone. This creates something called a 1-2 punch, which means that there's independent and synergistic effects on performance from both fluid and carbohydrate. When you think about it, it does make sense because fluid replenishes water losses and consuming carbohydrate ensures a continual source of blood glucose to fuel the working muscle. Key parameters for use of carbohydrate in fluid to reap the most benefit to endurance performance is the composition of the carbohydrate used and the administration, the timing of the carbohydrate ingestion. There are two proposed mechanisms for the use of carbohydrate to improve endurance performance. The first one relates mostly to the central nervous system, in that when we take in carbohydrate, it has a mental or cognitive stimulation by oral exposure, so the mouth exposure of carbohydrate, with exercise less than 1 hour. The second proposed mechanism is that carbohydrate has a direct contribution to energy production through exogenous carbohydrate oxidation during prolonged exercise when muscle glycogen is limiting, and this is usually with exercise that's greater than 2 hours in duration. Let's begin by looking at the impact of carbohydrate supplementation during exercise that's less than 1 hour in duration. First of all, for exercise less than an hour, muscle glycogen is not generally limiting. Several studies have shown that you can have an improved performance when carbohydrate is taken into the mouth. You're getting oral exposure, you rinse it in your mouth, and then you spit it out. So an example of this would be if you have Gatorade, you have a big swig of it, you mix it around in your mouth, and then you spit it out. And Carter et al. Showed this in 2004, where athletes would swirl in their mouth 25 milliliters for 10 seconds every 7.5 minutes. And what they showed was that their time trial, TT, their time trial was significantly improved by approximately 3%, which is the deciding factor between a podium performance and a mere finishing result. This research was just the beginning of a series of studies to explore carbohydrate mouth rinsing. And the majority of studies demonstrated that swirling with carbohydrate just in your mouth improved endurance performance, in that you didn't need to swallow the carbohydrate in order to see improvements in performance of less than 1 hour in duration. This was very new research, and previously everyone thought that you needed to swallow the carbohydrate and that the muscle was benefiting from taking in the carbohydrate. However, because muscle glycogen is not limiting during exercise of less than 1 hour, carbohydrate impacts the central nervous system. So what's the mechanism for this? Well, it really is driven from the central nervous system, that the oral receptors in the mouth are exposed to the carbohydrate, and these stimulate the pleasure and reward centers of the brain, which basically interfere and modifies the negative sensory information from the muscles, the joints, skin, core temperature receptors after prolonged exercise. And this feedback is indicating fatigue. And what happens is because these oral receptors are stimulated by glucose, they modify the message to the brain. And this leads to an improved rating of perceived exertion and improved motivation, altering central drive and the neurotransmission back to the muscle, preventing fatigue. Some limiting factors to this is exposure time, that you need to be able to swirl in your mouth for at least 10 seconds, which is sometimes not feasible for certain sports. And then you also need a high enough frequency of exposure to these oral receptors need to be exposed to glucose every around 5 to 7 minutes. So if the sport doesn't allow you to do this and doesn't have a spot for you to spit out the carbohydrate, then you can just swallow it. Carbohydrate absorption and oxidation appears completely irrelevant to enhancing performance of less than 1 hour in duration. The published recommendations for exercise less than 1 hour in regards to carbohydrate supplementation is approximately 1.5 grams of carbohydrate in 25 milliliters of fluid. So this was a 6% carbohydrate electrolyte solution, which is essentially Gatorade. It's at that formulation, or Powerade. Any of the commercial carbohydrate beverages are at 6% CES. And this is swirled for 5 to 10 seconds every 8 to 10 minutes of exercise. And it's not necessarily the most practical approach in that you need to be able to mouth rinse for approximately 10 seconds every 8 to 10 minutes. And this isn't feasible in various sports. Instead of spitting the carbohydrate electrolyte solution out, you can swallow it because it is Gatorade and you are getting some fluid intake. But there's no further benefits of the carbohydrate in the fluid to carbohydrate oxidation and improving performance.